Welcome everyone to the class of marketing research and analysis. So, in the last lecture we were discussing about confirmatory factor analysis. Confirmatory factor analysis is a technique where we understood which is based on a theory, right. It is unlike the exploratory factor analysis where the statistics decides which factors or constructs to be developed, but in the confirmatory factor analysis we are developing a model on basis of certain theory. This theory might be maybe a scale developed earlier by somebody, or some literature that you have studied, or through some, even sometimes some through some discussion with some experts in a field. So, you have developed a model and you feel it should behave in a manner that you are thinking. So, to test that we do a confirmatory factor analysis. Okay. So, in the last lecture while we ended, I had said, suppose you have developed a model and now the model is not showing a very fit model. So, how to check that and what should you do in that case? So, model diagnostics is the one which we will be starting the discussion today. CFA's goal is to see whether a given measurement model is valid or not, right. So, that means you have made a model. So, we know this is a covariance structure. So, right. So, we are trying to see, and each one has got, let us say, at least 3 variables. Okay. Now, we are saying whether this model that we have drawn is a valid model or not. Now, how do you know whether it is a valid model or not? To do that, we have some cutoff values, right, which we will say as the indices. Now, these indices will help us in finding out whether the model is a fit model or not. So, we will see. It also suggests modification of either addressing unresolved problems or improving the model's test of measurement theory. So, suppose you have while checking the fit indices, you found that the model fitness is low, right. In such condition, can you improve the model? Yes. Now, generally what people do, they when they when their model is not coming fit, so they panic and they try to do something which is unscientific. So, you need not worry about it. I will simply help you to understand how scientifically you can improve the model. Okay. Some areas that can be used to identify problems with measures are, for example, standardized residuals. So, what is the standardized residuals? I will explain. Researcher can use these residual values, right. Residuals, this word you have already used in regression also, where you are talking about the error terms, to identify item pairs for which the specified measurement model does not accurately predict the observed covariance between these 2 items. So, whenever let us see, let us take this, the generally the standardized residuals of less than 2.5 do not suggest any problem, right, but anything above 2.5 and specifically above 4 indicates serious problem and might lead to dropping of such variables. That means what? When you have a model, let us say, let us go to a model, right. So, I had opened a model, this is the model I had brought. So, suppose this is the model. Now, I am saying there are 4 constructs 1, 2, 3 and 4. The first one is linked to experience. So, there are 4 indicators of experience. Second is 3 indicators of happiness. The third one is having 4 indicators of trust, and the fourth one is having 4 indicators of word of mouth. So, when we are this is a CFA model, is a covariance model. Here there is no definite relationship. Now, what do you mean by definite relationship? Where we say that something moves from when there is a direction, A moves to B. So, this is non-directional, correct. So, there are moving both sides, it is a covariance. So, in such condition we will run this and see whether the model is valid or not, and then can we improve it. But before that, for some people who are extremely new to structural equation modeling and confirmatory factor analysis, for them let me explain how to draw a model first of all, right. So, I have brought a blank model. So, you see what I am doing is, suppose how to draw a construct. So, there are several ways. This is a construct, right. So, this is how you draw a construct. This is a indicator, right. So, let us say I have 3 indicators, right. I have 3 indicators linked to this. So, I say this is how I draw, right. So, this is how I draw, right, and each indicator will have a error term, right. So, each indicator has a error term. So, this is an so it has got an error term. So, now suppose instead of that can we do it little differently? Yes, we can do it. So, this is how you draw it. So, now same thing I have drawn it so easily, this facility has been provided to you. Now, once you you just click out in it so that this icon is gone. Now, you draw here. Now, suppose this is the construct, let us say something you want to write. Now, whatever you want to write. So, I am writing trust, okay, trust. So, this is my construct, right. Now, what is the variable? How do I bring the variables? Now, to do that I will explain you, just go to this file. Now, remember you need to have your data file ready. Now, the data file is the file which from where you will collect import the data. Now, the file name I am giving is let us say the CFA file, right. So, let me take it out, open, okay. Now, once I have done with it, I will go to view, variables in data set, and now there are trust. So, trust 1, so I am pulling trust 1 here, I am pulling trust 2 here, I am pulling trust 3 here, okay. Once I have done, now suppose you want to also do the same for this one, let us say this is let us say experience, I am taking experience 1, experience 2, experience 3, okay, and this one I will name it as experience, okay. So, this is experience. So, let me draw it for you, experience, okay. This is all I am writing. Now, since this is a covariance structure, so I will draw a covariance model, right, CFA is covariance. So, now this is what? Now, this if you see there are some unobserved, these are error terms, right, they have to be given name. So, just go to this place, name unobserved variables. So, each error term has been given a name, correct. Now, you can run it, okay. So, this is how you draw the model. So, my interest is only to show you how to draw the model. You want to make any changes, so all those icons are there, right. So, copy, so you want to copy something, you can copy, for example, I want to copy this and I want to paste it here, right. So, I want to or I want to just move something from this place to this place, I can drag it here. So, these are all the icons which the more you play you will realize more and more, you will understand more and more, okay. So, I am stopping it with this, okay. Now, I will go to my model of interest, now this one. So, already my data file is connected, okay. So, what I am going to do is I am going to first run this model and see whether this model is a valid model or not. Now, how do I run? Now, this icon you can see is what it says about running, right. So, but one thing, before you run you need to go to the output file. See, this is a maximum likelihood condition. Now, go to the output. Now, I need certain, for example, the residual elements. Now, if you go back to this file, what did it say? I need this standardized residuals. Generally people get confused to where do we find this, okay. So, this is the residual moments, right. So, you have done it. Now, I have run it already, I think. So, let me run, no issues. So, okay. So, this is my output file, okay. Now, first let me check my model fit. Now, before you understand, you see the values, let me tell you, there is a chi-square value because this model is based on the chi-square technique. So, this chi-square minimum by degree of freedom, this value is should be around less than 3, preferably less than 3, and if it is more than 3 or 4 and especially more than 5, then it is the model is a weak model, right. So, the lower the chi-square by degree of freedom, the better it is, okay. Now, this GFI, AGFI, NFI, IFI, TLI, right, these are all different indices. So, CFI. So, these indices if you go back to my slide, I will show you this indices, yeah, this is the indices, absolute fit indices, right. So, this fit indices are, for example, goodness of fit indices, right. Each model when you test a model, at least you should take each from each indices you should take one, right. So, for example, the goodness of fit indices, this was an attempt to produce a fit statistic that was less sensitive to sample size. Now, what is for a normal person, for somebody who is new, you understand that higher the value, the higher the better is the fit of the model. So, the cutoff value has been kept as 0.9. So, GFI is above 0.9, it is considered to be good, right. The adjusted goodness of fit, similarly this should also be 0.9 or above, right, close to 0.9. But remember, do not ever worry, because sometimes this 0.9, although it may be a very stringent, it is a measure, is a cutoff value, but this might, if you get something around 0.8587 also, you need not worry. If your sample size is very large, it is sensitive to sample size. So, if you get a slightly lesser fitness value, then also you should not worry, because if you have a large value sample size, it will be very sensitive and this might come low, right. So, you need not bother about it, but you have to check your sample size, right. Similarly, the chi-square, right, this value, right, which tells about the difference between the estimated covariance matrix and the observed covariance matrix, right. So, this value also we are trying to check the chi-square by degree of freedom. Okay. So, this should be preferably less than 3, as I have mentioned here, right. RMSEA, this is another indices, right. It examines the difference between the actual and the predicted covariance model, right, and the value of 0.08 or less is desirable. Okay. You can go back to the formula, check the slides later on and read it slowly, how is the formula developed, but let me at this point let me explain you its meaning. The root mean square residual is another such indices which is also has a cutoff value of about, let us say 0.05. Okay. So, if it is less than this, it is better, the model is fit, right. So, these are different fit indices. Okay. NFI, it is the difference in the chi-square value of the proposed model and the null model, the baseline model. You must have, you will see when you use MOS or Lizarel, this is called a baseline model. This baseline model is the null model, okay, divided by the chi-square value of the null model. NFI is also should be above 0.9. Similarly, the CFI is a improved version of the NFI, right, but it CFI is similar to NFI, but it penalizes for the sample size. So, higher sample size more sensitive and it should be 0.9. So, there are several say Tucker-Lewis index. So, these are some several fit indices. Okay. So, now let me show you what we have got. Now, we were here in the MOS output. Now, we said it should be less than 0.3, correct. Now, let us see, can we make some improvements in the model. Now, and you see the NFI is 0.783, GFI is 0.785, CFI is 0.839. So, generally if we see the cutoff, the model's cutoff values are low, right. Now, how do we improve? Now, let us go to the estimates, right. So, there are two things, scalar and matrices. Now, go to the matrices, right. Now, when you go to this, we want this standardized residual variances. Now, let me drag it a bit. Now, look at this this correlation matrix. Now, if you see, look at any value, try to find out the highest value, which is the one which is where the value is more than 4 and above, right. So, 4 and above, I think WOM 4, right, this one is has a very large impact, right. The higher the values with the other, when it is the covariance values are very high. So, 4.426, 5.9, 5.092. Similarly, trust 3 also, if you see, it is all about 5. So, why not first start with this trust 3. So, we go to the model, see trust 3. So, we first start deleting this trust 3. So, I am deleting trust 3, okay, it is error term also. Now, one by one we will go and we will run this model again. You remember the chi-square by degree of freedom, 3 point something, 1 or something was there. Now, run it again. Now, let us go to the output, let us check the model fit. Now, you see there has been a significant change, 2.709, and have the indices improved, GFI 8.833, CFI 0.844, which is better than the earlier, right. Now, let us see, is there any other variable similarly responsible for the downfall of this model, weakness of the model. Now, yeah. Now, let us go to this WOM 4, right. So, we go to the model again and we will see if we can, if we remove this WOM 4, what is the change, right. Now, we will run the model again. Okay. So, has there been any improvement? 2.7, now 2.2. So, from 3.1 to 2.7, now 2.2, and look at the GFI, the AGFI, the CFI, and if you can see, there has been significant changes, right. Now, let us see, can we is there any other such covariance the relationships which are keep making the model weak. So, again let us go to the estimates and check finally for the last time. Oh, there is trust 4 which is also above 4. So, we can play with this trust 4, right. So, I am removing trust 4. Okay. So, we will have only maybe 2 values of trust. Now, finally, we will run. So, model fit. So, now it is 1.912. So, there is a significant improvement. The GFI values have become above 0.9. So, which is good enough. Suppose now you want to check again, is there some value variable which is still responsible. Now, we can see there is nothing above 0.4. The cutoff value is in fact 2.5, and above 2.5 to in between 2.5 to 4 it is you may treat it. If you do not treat it also no issues, but above 4 you should surely treat it, that is an item for deletion, right. Now, there is no such problem. Now, still if you want to see make an improvement, suppose this would have been the table and you see your model fit is, let us say you want this would not have been 1.9, something like 3.9 or something, or 2.9, then can I make some improvement? No, yes. What do? You go to the modification indices, right, and when you go to the modification indices, see within the same construct which are the items or which are the error terms which have a relationship. You should never, this is theoretically wrong to draw a covariance between a construct and a error, you should not do it. Between 2 error terms, and that too within the same construct, you should first check for it. So, 12.830 is it within the same construct? Let us see, E3 and E4, yes. So, these two, there is if we make a covariance, it says that there will be an improvement in the model, right. Now, let us run. It was 1.9. Now, let us see, is there any improvement in the model? 1.670. Look at all the values, right, and this is an improvement. So, you can do further also, you can again check for modification indices and see whether there is any any such relationship, E2, E5, right, E3. So, this is so fine, right. So, this is not to be connected. So, E2, E5, E2, E5, is it within the same year? No. So, that means there is no more improvement possible in the model. So, we stop here. So, now this is your final CFA model. Okay. So, as I had said, so this is this helps you, correct, to identify which items to indicators to delete. Okay. Similarly, the modification index which I just did it and showed you is calculated for every possible relationship that is not estimated in the model. A modification index of approximately 4 or greater suggests that the fit could be improved significantly by freeing the corresponding path to be estimated, right. So, making model change basically solely on modification indices is not recommended. So, you should first try to see the residuals, and after that you can go for the modification indices, and I have given you some conditions, like for example, do not try to draw a relationship between error terms of 2 different constructs, and do not do it too many things at one time, right. That means 2 error terms together at the same time, do not do that. Go for one by one, the highest which has the highest value. So, one by one, and you should not also, theoretically it is also wrong to connect a construct with a error term, because the software will do it, but then theoretically that it is wrong actually, you should not be interpreting that way. So, this is what we have understood. Now, there is one more example I have brought for you to because after this, once you are thorough with the CFA, then we will get into the after the measurement model is found to be fit, we will get into the structural model. Okay. So, here this is a case which I have brought. This is a case of ABC Paper Industries. The company deals in finished products made by papers. They employ around 1000 workers. Like many other companies, they are facing the problem of attracting and keeping productive employees. The cost of replacing and retaining employees are high. ABC management wants to understand the factors which contribute to employee retention. So, it wants to test a measurement model made of factors that affect the employees' attitudes and behaviors about staying with the company. So, first we will define the individual constructs. So, let us do that. With the general research question defined, the researcher now selects the specific factors that represents the theoretical framework to be tested and will be included, right. So, what are the constructs? Now, they have seen job satisfaction, organizational commitment, staying intention and environmental perceptions, attitude towards core workers. These are some of the variables or the constructs that would be a part of this study. Job satisfaction reactions resulting from an appraisal of one's job situation, commitment, that is extent to which an employee feels part of the company, staying intention, the extent to which an employee wants to continue working with ABC. See, remember, in the measurement model we are not saying anything is dependent or independent, it is just a covariance model, there is no direction as such, right. So, these are the 5 constructs we are having. So, job satisfaction JAS, organizational commitment OC, staying intention SI, environmental perceptions EP, right, that means belief of an employee about day to day physical working condition, right, and attitude towards co-worker AC. Each you see each construct has several indicators. So, job satisfaction has JS1, JS2, JS3, right, there are, right, you can check from here, you can read all this, right. So, then we develop the measurement model. So, with the construct specified, the researcher must specify the measurement model to be tested, right. Okay. So, this is the measurement model. Okay. So, job satisfaction, organizational commitment, staying intention, attitude towards co-workers, environmental perceptions, and you see they are all correlated, right. So, we have a theoretical understanding how they are correlated. Okay. So, this is all you can see the correlation, right, this is a covariance structure and each of the indicators are connected with the, and you can see these are reflective constructs, right. So, that means the latent construct is explaining the variables, okay, and each variable what does it mean, suppose SI1 what does it mean, you can check here. Now, let us run this, we have this file in fact with us. So, we have this, right. So, I have already connected it to the data. Now, you try to understand first what we do, we will take, we have already run, so it is already there. Now, let us run the model, right. I hope you can draw the model at the moment by using these icons. Okay. Now, first let us check the model fit. The model is, because it is already we have tested and tried and tested, already this model is coming a very clear and very robust model. Look at the C mean by degree of freedom, the chi-square by degree of freedom, it is 1.323, right, and look at the GFI, the goodness of fit indices. This is what you need to report, correct. When you write your paper, research paper, you need to write that the chi-square by degree of freedom was this much, the GFI value, the AGFI value, you can take one from each, right. So, and the RMR should be less than 0.5 as I had said, and baseline you can say out of NFI, RFI, IFI, CFI you may take 1 or 2 of this. So, all are above 0.9, right. So, once we have done, now there is no need for improvement, but the model is by default we are saying the model is an improved model, that means we can say the model is a strong model. Okay. That means what does it mean, the difference between the observed and the estimated model is very little, right. Now, suppose you would have needed some improvement to check, then what you would have done, go to the estimates, right. Now, this is an important, now you can, although this is less important, but this is important for us, this side. Now, is there any insignificant thing, any insignificant relationship? No. If there would have been an insignificant relationship, then we would have deleted. Now, let me go back to the earlier one slide which I had drawn. Okay. Now, let us run this, right. Okay. So, go to the estimates. Now, you can see some of them is okay, we have already done it, otherwise maybe the ones which you deleted, there we deleted some from the residual errors would have also shown here, maybe they would have been insignificant at this, this place it would have. For example, you see the relationship between WOM1, right, and the fourth construct WOM1 and 4, right. So, 4 and WOM1, this is still coming insignificant, that means if you delete it, now look at the model fit, first go to the output, right. Now, look at the model fit. So, 1.67 and whatever you are getting. Now, if I delete it, Now, this is a good thing, suddenly we got it, it struck my mind. So, I think WM1, yeah, 0.493 WM1, right. So, let us remove this. So, suppose I remove this, right, and now let me run the model again. Now, you see, now go to the model fit, must have improved. Okay, the problem here is 1. What has happened? This is good that this problem has come to you. Now, everywhere there is a parameter, the fixed and a free, every parameter has to be explained, right. So, there is one more way I can show you where you can see whether some of the indicators are fitting or not. So, as I had explained, you can run the model, go to the estimates, right. So, in the estimates, first you look for the model fit normally. So, it is how it is there. Now, go to the estimates. Now, I had said, if you remember, that the estimates need to be significant, right. But here this is very interesting. What is the if you see this one trust the construct 3 with the trust 4, right. This is a 0.952, right. So, 0.95, this is not significant, right. So, we have a cutoff value of let us say 0.01. So, it is much above it. So, that means with the null hypothesis cannot be rejected, which is says that there is no relationship that is to be cannot be rejected. Okay. So, now, so when you find this, what you can do is go to this and drop this model trust 3, I think it was trust 3, right. So, what you do is trust 3 you can delete it from here and keeping other things the same, you can rerun the model, right. So, this is also a good way to understand how to improve your model. Now, let us see the estimates. There are a few, for example, trust 4 is also there. So, you can check. Now, this data, every data set is different. So, when you do this, so you can understand where to, how to improve. So, I said through the estimates you can go and check for significance. I also explained to you how through the residuals you can go for something which is above 4 or something and try to delete those variables, and if there is no problem in that, still the model is not improving, then you can also see for modification indices, right. So, these are the 3 things that you can check to improve your model. If suppose still it is not going correct improving, then do not worry, then you have to go back to the field and check your data again, right. So, now coming to the slide. So, we were here. So, as I was working on this job satisfaction, this okay. So, this file we were working. So, I think yes, this is the one. So, we had run this and we were checking his model first. So, the model was fit, everything was good. So, this model says now this is everything is good, right. Now, estimates, let us look at the estimates. Now, although it is not a directional study like a structural equation modeling or a structural model, in the measurement model we are not worried, but still this helps us to identify whether any of these indicators are giving a poor result to the entire model. So, had it been a not significant case, then it is an item for deletion as I had just shown to you, but here in this case there is no such problem. That means, now if you go back to the model, that is how you do this, right. So, you have drawn all these things and now the the model has been drawn, and these things you can check later on how to take the values into here, and finally we will come to the scores, right. Okay. This is how the model will look like. You see 1.323 and the GFI. So, here this is how you write. To check the overall fit, click on the model. This chi-square degree of freedom is less than 2, which is considered very good. CFI is over 0.9, RMSCA is less than 0.05, GFI is greater than 9. So, this result shows that the ABC measurement model provides a reasonably good model fit and is suitable for further examination of the model results. So, this is only one part. The measurement model says that the model is good and it is can be tested in the for the relationship as in the structural model. Okay. Construct validity, to assess the construct validity, we will examine the convergent, discriminant, homological validity in this case only. So, convergent validity, as I have already explained, right. Let us see here. In AMOS output, click on the estimates and then see the standardized regression weights. Okay, this regression weights taken together, the results support the convergent validity. Why? All 3 loadings fall below 0.7. So, there are, you see it should be, we said 0.7 but at least it should be above 0.5. So, nothing is below 0.5 here, right. That is, everything is more than 0.5. In addition, the model fits really well because the chi-square by degree of freedom is 1.323, right. Now, how will you check for discriminant validity? The conservative approach for establishing discriminant validity compares the AVE estimates, which I had shown you in the diagonal. It should be the AVE scores, if you take the constructs C1, C2, so C1, C2, C3, C3, and you take the AVE loadings, right. So, this loadings AVE scores should be more than the square of the correlation among the loadings, right. So, the AVE score should be greater than the corresponding inter-construct squared correlation. In our example, the AVE score was greater for each factor, therefore, there are no problems. Okay. So, this is how finally you write the CFA has completed, the chi-square is significant above the 0.01 level. Both the CFA and RMSE appear quite good because of the, you have to show the values, right. Overall, the fit stat suggests that the estimated model reproduces the sample covariance matrix reasonably well. This is the most important finding. Further evidence suggests a good construct validity. Thus, ABC Paper Mills can be fairly confident at this point that the measures behave as they should in terms of the unidimensionality of the 5 measures. 5 measures are the 5 constructs, and in the way the construct relate to each other. But here you have not said which construct affects the other in which way, because no direction has been provided, right. So, only we say that the model is a valid model and the construct relate to each other. So, this is all you do in the CFA, correct. So, in the next lecture I will explain to you once within taking the same example how to explain the relationship or provide a direction and check whether there is a relationship exists, and if it exists, how does it exist. Okay. So, this is all for the day we have. Thank you so much.